Well, dear friends, in last video I told you about Einstein theory of photoelectric effect. Now, the equation used by Einstein is called Einstein Equation of photoelectric effect, and that was given by me here as Ek equal to h nu minus w. Ek represent maximum kinetic energy, h nu frequency or energy of photon, and w is our function of matter. Now, experimentally, the maximum kinetic energy of photoelectron is given by Ek equal to E into V. V0 I must write here E0. Here E is the charge of electron and V0 is the cutoff potential. Equal to magnitude of charge of electrons, and V0 is cutoff or threshold potential. I have defined cutoff potential in last video. So this equation, suppose one, can be written as EV0 equal to h nu minus w. If V maximum is the kinetic energy, also is in terms of velocity. So if V max be the velocity of electron having k बराबर Ek, then equal to half mv maximum square. Therefore, Einstein equation can also be written as half mv maximum square equal to h nu minus w. This is also used. Now if frequency of radiation falling on photocathodes is equal to mu 0. That is critical frequency. Then ek is 0, as from the graph ये कहाँ से आएगा, ग्राफ ये था ना हमारा E K means maximum energy and frequency. The curve was like this. So it is mu 0 at which energy is 0. So using mu equal to mu 0, we get 0 equal to h mu 0 in equation 1. Equation 1 is there, Ek equal to h mu minus w. Using Ek 0, mu equal to mu 0, we get this. Or from here w equal to h mu 0. And therefore, if we know work function of metal, we can find out critical frequency. Or conversely, if we know critical frequency, we can tell about work function. This graph actually is very important. I will discuss further. So equation 1, hence Einstein equation. Einstein's equation can also be written as Ek is equal to h nu minus h mu 0, or Ek equal to h nu minus mu 0. From this equation, if I take this is mu 0 and this is nu, and this represents k, Ek. So Ek upon nu minus nu 0 here. Here we get this equation as equal to Ek upon nu minus nu 0, where h Planck constant. From this we get that slope of graph between Ek and frequency nu is equal to Planck's constant. This fact is very important for exam point of view. Generally, you are given the graph and you may be asked from the graph find Planck constant. Sometimes this graph is given between cutoff potential and frequency. The graph again comes the same way. But now here, you know cutoff potential multiplied charge of electron. So here H will be E into, if this is V0 and this is V here, then E into V upon nu minus nu 0. Yani slope of cutoff potential and frequency slope of this multiplied by charge of electron is again Planck constant. You can be asked like this also. And here this, I told you this intercept work function. So all this was all about Einstein theory of photoelectric effect. Dear student, this online teaching had a very bad effect on the learning of calculation on average students. Actually, I have seen now every year I get variety of experience. Yesterday I met a girl in function who got more than 90% marks. When I asked her how are you studying, she told me I am learning online and I am doing well. Okay. While conversing with her, anyhow I asked 0.1 square. So the girl was very much confused. She told me again 0.1, ke 1 1 ja 1. She forgot that there is decimal. One student told me 0.1 square is equal to 0.2. Please be aware, do practice, nothing else. Actually, why do we commit such mistakes? We commit these mistakes because we are not in practice, and as soon as we have been asked a simple question, we give the answer in a hurry, and that hurry made by us force us to commit mistake. So please do practice. So here I have time for you. So I want to tell some how to calculate and how to remember the things. I told photoelectric effect takes place when high frequency radiant light, ultraviolet or visible light is incident on metal surface, and all the radiation are unable to give photo emission. The radiation below critical frequency are not able to give photo emission, and the minimum energy required to take the electron out is measured in terms of critical frequency and work function. W is equal to h nu 0. Here in our book there is a table on work function of metals. Please see that also. In NCERT book, it is on page 388. This table is there. You can see here metals and their work function in electron volt. Cesium 2.14. Cesium metal has the least work function, so photo emission takes place more easily than platinum has maximum 5.65. So you certain in some exam you may be asked which metal has maximum value of work function and which has the least. So please keep on reading these tables also and try to grab in mind work function of cesium is 2.14 electron volt and that of potassium 2.30, 2.75, so and that of platinum this. Now why I am telling here, because you know kinetic energy is equal to Ek equal to h nu minus 1. If frequency, that is the energy of photon more than one function. then Ek will be positive and will be electron ejected. If this H nu less than this, if H nu less than W, then Ek is less than 0 negative. No electron will be emitted. Our visible light has wavelength from 7,500 angstrom to 4,000 angstrom, and correspondingly you can find out frequency range. It has the lowest frequency range, it has the highest frequency, and other in between. So I may ask you here to find the energy of photon of wavelength 4,000 angstrom, as nu is equal to C upon lambda, so E equal to Hc upon lambda. It looks very simple question, but when you are asked the answer in electron volt, you are in trouble. First of all, I want to tell you how to calculate E energy Hc upon lambda at 6.63 into 10 to the power minus 34. See the speed of light 3 to the power 8. Lambda 4,000 angstrom. I have told many times 1 angstrom 10 to the power minus 10 meter. So it will be 4 into 10 to the power minus 7 meter. This answer of energy, the value of this energy will be not electron, it will be in joule. Be aware of the unit. But you are asked here, answer in electron volt. I have told you many times that 1 electron volt is the energy gained by electron when accelerated through potential of 1 volt. And 1 E we write like this, small e capital V is equal to 1.6 10 to the power minus 19 joule. So to find this value in electron volt, 6.63 into 10 to the power 715. Collect the power. 7 plus 8, 15, minus 34 plus 15. It will come out 19 minus 19 upon 4. We have to convert the electron divided by this. 1.6 10 to the power 19. And write here E capital V electron volt. Write the unit first. Power cancel. It is 6 3 18, 6 18 upon 6.4. So if we divide this, it will come out nearly 3 point some electron volt. This is 3.01 kuch aayega electron volt. It is the maximum energy of light, of visible light, photon. If we take this one, so now energy of photon, so 3 point electron volt. Tell me. So now energy of photon of 7,500 angstrom. I can take here 7,000 again also. So that E equal to Hc upon lambda right there, 6.6 10 to the power minus 34. Please do it yourself. Don't think that we have done, I read and I can do. Take another wavelength and find the value of energy. 3 into 10 to the power 8 upon lambda 7.5 10 to the power minus 7. Let me convert it here to joule. Again power get cancelled. 26 power cancel. Now it is equal to, actually now it has become simple, 2.5. So 6.6 upon EV into 16 5 80, carry 8, 16 to 30, 40. So decimal here, that's why. I knew, do such a practice that you can know the answer में क्या आएगा. Electron volt. Divided by 4 simply, or 6.6 upon 4. 4 1 जा 4, 2, 4 6 जा 24. By 6.6, 4 ja 2.6. I am doing for your simplification. Again 2 0, 4 6 ja 4 5, sorry. So 6 5 electron volt. So this is the lowest actually. In general, we take up to 7 electron volt, 7000. So if lambda is equal to 7000 angstrom, then this E will be nearly 1.8 electron volt. It goes into the region of infrared heat radiation. The radiation carrying heat energy has longer wavelength, and energy of photon carrying heat energy is less than that of visible light. So energy of range of energy of photons of visible light is 3.01 electron volt to nearly 1.8 electron volt. These are, now if anyhow you know that one function of cesium is 2.14 electron volt, then directly you can say that photo emission will take place directly. If you are doing calculation, you are asked to do calculation, then you are sure that photo emission will take place. If you do mistake, then you can tell your mistake yourself. So this is something about photoelectric. I will come to numericals and other things later on in the coming videos. Thank you.